Section 12.3 is determinants and inverses. I can find the inverse of a matrix. Big ideas here. The product of a matrix and its inverse matrix is the multiplicative identity matrix. Not all matrices have inverse matrices. A matrix has an inverse if and only if its determinant does not equal 0. So as long as the determinant doesn't equal 0, it has an inverse. A square matrix is a matrix with the same number of rows and columns. So a 2 by 2, a 3 by 3, 6 by 6. Okay. Take note on page 782. Says for an n by n matrix, so a square matrix, the multiplicative identity matrix is an n by n matrix I, or I sub n, with ones along the main main diagonal and zeros elsewhere. So it has to have ones here, and zeros everywhere else. Ones and zeros. If A and B are square matrices, and A times B equals B times A equals I, then B is the multiplicative inverse of matrix A. And we write that in inverse notation, kind of like we did with our F inverses a few chapters ago. In example 1, to determine whether these are inverses, we need to check both A times B and B times A. So, A times B, 1 times negative 2, plus 2 times 3/2. 1 times 1 plus 2 times negative 1/2. 3 times negative 2 plus 4 times 3/2. And 3 times 1 plus 4 times negative 1/2. Let me simplify here. Negative 2 plus 3 is 1. Here I have 1 minus 1, 0. Negative 6 plus 6, 0. 3 minus 2, 1. Okay, now we just need to make sure that B times A is the same. So B times A I'm going to go negative 2 times 1 and 1 times 3. Guys, if you want to rewrite these in that order, you certainly can. I'm going to go negative 2 times 2 and 1 times 4. 3/2 times 1 plus negative 1/2 times 3 and 3/2 times 2 plus -1/2 times 4. Simplify here. -2 plus 3, 1. -4 plus 4, 0. 3/2 minus 3/2, 0. And 3 minus 2, 1. So here we have A times B equals B times A equals our identity, 1, 0, 0, 1. So, are these matrices inverses? Yes. Because A times B equals B times A equals our identity. Okay. A times B again. I'm going to have 1 times -1 plus 0 times -3 plus 2 times 1. I'm going to do 1 times -2 plus 0 times -4 plus 2 times 1. I'm going to do 1 times 2, 0 times 5, 2 times -1. Next row, -2 times -1, 1 times -3, 1 times 1. -2 maybe times, what am I at? -2, 1 times -4, 1 times 1. I'm going to go -2, times 2, 1 times 5, and 1 times -1. -1 times -1, 1 times -3, 2 times 1. -1 times -2, 1 times -4, 2 times 1. And last one here, -1 times 2, 1 times 5, 2 times -1. Now I'm going to simplify this here. -1 plus 0 plus 2 is 1. Here I get 0. Here I get 0. Here 0, 1, 0, 0, 0, 1. Perfect. That's what we're looking for. Now let's check B times A. And I'm actually going to erase all these to make it a little bit easier to look at. Maybe, if it'll let me. Start over. Now I'm taking row in B times column in A. So, negative 1 times 1, negative 2 times negative 2, 2 times negative 1. Negative 1 times 0, negative 2 times 1, 2 times 1. Negative 1 times 2, negative 2 times 1, and 2 times 2. Negative 3 times 1, negative 4 times negative 2, 5 times negative 1. Negative 3 times 0, negative 4 times 1, 5 times 1. Negative 3 times 2, negative 4 times 1, 5 times 2. And last row here, 1 times 1, 1 times negative 2, and negative 1 times negative 1, 1 times 0, 1 times 1, negative 1 times 1, and last, 1 times 2, 1 times 1, negative 1 times 2. Simplify these here. 1, 0, 0, 0, 1, 0, 0, 0, 1. Super. So we have matrix A times B equals matrix B times A equals our identity. So our answer here is a yes again. Okay, let's try one more here. A times B, 2 times 2 plus negative 4. Two times 5 minus 12. 2 times 2 negative 2. And 2 times 5 minus 6. So A times B here is 0, negative 2, 2, negative 4. Sorry, positive 4. Guys, as soon as we know that one of these isn't going to be our identity matrix, we took matrix A times matrix B and didn't get 0, 1, 1, 0. We know automatically that they are not going to be inverses. So we don't even have to find AB. We know that they are not inverses. Okay, that is all the time I have for this first video.